You can in between answer my questions. Am I audible?
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
Okay.
sir.
So in the previous period, we have studied the Newton's first law, and then we have completed even the Newton's second law. In brief, I am going to tell you in this now. Newton's first law speaks on inertia. And what is inertia? Inertia is a property of a body to be at rest. Suppose if a body is at rest, okay, it resists any change in its position, it opposes any change in its position, right? And that is what is called, you know, inertia. It's a property of a body to resist any change in the position. So if it is at rest, it will oppose any change we make to make it move. Or if the body is in motion, if the body is in motion, again that opposes to come to rest, and that property is called inertia. Please pronounce it properly. And that itself is the Newton's first law of motion. And then we have seen what is Newton's second law of motion. We have understood that acceleration depends on mass and force, right? If the force is more, the acceleration will be more. So we can write acceleration is directly proportional to the force. And then we have understood that if the body is heavy, then acceleration sometimes will be less. So acceleration is inversely proportional. This is how it is to be written, which we have studied, to a mass. So if you combine these 1 and 2 equation, you will get acceleration is proportional to F in the numerator and then m in the denominator. Now, this can be made equal, or on cross multiplication it can be written as a into m. So it's a cross multiplication. I'll write m into a is proportional to, this remains as it is, to force. So let me write here, right? Force is proportional to product of mass and acceleration, and this is what the Newton's second law. If you write in statement, you have to write a force applied on a body is directly proportional to the product. You should not miss this word, product of mass and acceleration. Now after that, if you want to use it in calculation, you cannot keep this a proportional sign, you have to make it equal sign, and when you make it equal sign, you have to multiply by some constant, which we are using a letter as k, m into a, and we saw that k value of k becomes 1 in SI unit, and therefore F is equal to m into a. So for the question that what is Newton's second law of motion, give a statement, what you have to do is you have to write this much, right? This video will be uploaded, you can take a screenshot, and I will also give you notes on this, right? So this is very important part of Newton's second law, right? And after that we have seen one problem related to Newton's second law and previous portion, that is motion, right? So in this case what we have studied is, right, a truck starts from rest, that is very fast. I will be moving here because we have completed 0. It starts from rest and it has a constant acceleration, right, and it travels a distance of 400 meter, right, and it gets a time t is equal to 20 seconds. See how fast you can do. Find the force. So F is equal to question mark, and the mass is 7 metric ton, which is equal to 7,000 kg. If you want to find a force, then you have to use the acceleration and mass, that is Newton's second law. F is equal to ma, but there is no acceleration with us, so we have to find acceleration. And how we can find acceleration? we have three equations here. V is equal to u plus at and s equals ut plus half at square, and then v square minus u square is equal to 2as. Now you have to see what is available. Here we have a and t also we are given, but v final velocity is not given, so we cannot use this. But here s is there, s is 400 meters, and t is there, t is 20 seconds, and then u is there, u is 0, so we can very well use this equation. Therefore, quickly to find a, we use second equation of motion. S is equal to ut plus half at square. I hope I am audible to all of you. So 400 is equal to this, since u is 0, this entire function becomes 0, plus half into a remains same because we have to calculate this, and 20 square, right? So therefore 400 is equal to 0, we need not write, 1 upon 2 into a into 400, right? And therefore I'll just reverse this, 400, this is 400a divided by 2. 400a divided by 2 is equal to 400, right? And therefore a is equal to 400 into 2, this goes, divided by 400. So 400 gets cancelled, 2 meter per second square, right? So once we came to know about what is a, we can find what is f. Next equation is f is equal to m into a, and m is 7000 kg into 2 meter per second square, which is equal to 14,000
meter
kg meter per second square, and that is equal to 14,000 Newton. Okay, so please remember 1 kg meter square is equal to 1 Newton, and therefore 14,000 kg meter square is equal to 14,000 Newton. Is that okay? Understood? Tell me now, you can answer.
Yes, sir.
Okay. Now, now we have many such questions now. So what I'll do is, I'll just skip some of the questions. We'll take this little later. So in this period, I'll go to another concept. There are many questions which we have. We'll solve this in the next period. Okay. So here what we'll do is, I'll take you to another concept which is more important now. Okay. Once we complete this chapter, the main content and theory, we will come back to this numerical part of it, problem solving part of it, right? So let me tell you what is momentum. Okay, very interesting concept, momentum. So be with me now here in understanding this, what is momentum, right? So our next picture is, can you tell me who is this bowler?
Sir, Shoaib Akhtar.
Shoaib Akhtar. So what do you know about him? What do you know about him? He's the fastest bowler so far, right? He's the fastest bowler so far. How much? You know, from Pakistan he is 161.3 kilometer per hour. So the ball which is in his hand, the moment his arm gives that ball out in the air, and it will be traveling 161.3 kilometer per hour. You just think it will be moving just like a train. Our fastest train is about 160 kilometer per hour. Okay, so fast. So why I am telling this? Let me come back to this. Who is this chap? From which country?
Australian player, sir.
Australian player. Brett, right? So he is almost reaching 160 and above kilometer per hour, right? African elephant, bush elephant, which will have a maximum speed of 40 km per hour. Now look at this. 161 km per hour, the ball moves out of brittly sand, and 40 km per hour, this Australian elephant moves. Right? So keep that in your mind. It's around 6,000 kg. The weight, the mass, we have to refer it as a mass. The mass of this elephant is approximately around 6,000 kg, and the mass of the ball will be around 1.5 kg. It differs slightly sometimes. Okay, for women cricket, the ball which is they are using is less, whereas the men will be having around 1.5 kg. Well, you understood the mass of the cricket ball and the mass of African elephant. Now, train.
Sir, elephant is applying more force, sir.
Well, we'll come back to that question. Right.
Its
160
inertia
km
is
per hour, fastest train in India. Vande Bharat. Right? And how much it is? 80 tons weight. It's about 80 into 1000 kgs. 80,000 kgs approximately. Now, we'll come back to the main point. All these motions which we have seen now are depend on two things, and they are a mass and velocity, or you can call it as speed. Okay, motion of a body depends on mass and velocity, and that body gets a kind of property when there is a mass and velocity. Right? You can even think of carom board, and in the carom board there will be a striker here and the pieces are here arranged. Right? When it is forced onto this, it's a striker which strikes on this, and then these pieces will move away. Okay, and sometimes you will find these pieces will move away with more speed than the speed of the striker. You just push it and this will move with a more speed. That means striker has got some property, and that property is because of mass and its speed. Let's say, what is that? If there is an object, right, whose mass is 10 kg, object whose mass is 10 kg and which is moving in velocity, let's say 1 meter per second. So be with me here. A mass is 10 kg and velocity is 1 meter per second, right? And therefore, what is the product of mass and velocity? So when we multiply the product of mass and velocity, we will get, m into v. That is what is called momentum. So please remember, momentum. So if you are asked to define momentum, momentum is the property of every body. And what exactly it is? It is a product of mass and velocity. Right? Please remember this. Now, let us find out the momentum of this body. So, for example, we will take a car here. Better take is a car. Or we can even look at this momentum. Okay, I'll just do momentum of this. Momentum of this is, we have to find out what is mass and what is velocity, and simply multiply m into v. So what does it give?
Sir,
M is 10 kg, right? You can speak, you are allowed to speak. 10 kg.
sir, what is a unit of momentum, sir?
That's, I am exactly coming back to that. Okay, when we do this calculation, we will be understanding. So mass is what? 10 kg. 10 kg, isn't it? And velocity is 1 meter per second. So when we multiply mass and velocity, how much of number you will get here? What's the figure?
Sir, 10 kg meter per second.
Well, 10 kg meter
Meter per
per second. Why this kg meter per second? Because since it's a product, we have to multiply even the units. And exactly this kg meter per second is the SI unit of momentum. So momentum will be written in kg meter per second and its symbol is V. So in this example, what is the momentum of this object? P is equal to 10 kg meter per second. Let us take a car which is already moving, right? And the car has a mass of 1000 kg. Generally car will be around 1000 kg. And let's say it is moving, already moving. It is not that there on the rest. So its velocity initially is 1 meter per second, and when it goes here, its velocity is 20 meter per second. Okay, just be with me here. Its velocity was 1 meter per second, and then when it goes for further distance after some time, its velocity is 20 meter per second, right? Mass remains 10 kg, 1000 kg only. Now, this velocity which the car has initially, therefore you can call it as the initial velocity. And what is the symbol which you use for initial velocity? U, right? So we can straightway write U equals 1 meter per second and M equals 1000 kg. And what is V? What is U? U is velocity only, but initial velocity. And what is final velocity? Final velocity is 20 meter per second, but the weight, that is the mass, is 1000 kg. Now here we will find out the momentum. Okay, here we will find out the momentum. Momentum here at this point we'll call it as P1, and momentum here at this point we'll call it as P2. Okay, what is the initial momentum? This momentum is called initial momentum here. If you find a momentum here, it's the initial momentum. And tell me now, what is this momentum called? Hello?
Final momentum.
Final momentum, sir.
Final momentum, right?
Final momentum, sir.
Okay, now here the momentum will be initial momentum, which is equal to m into u. So please remember, mu stands for initial momentum. So how much? M is 1000 kg into 1 meter per second. Now tell me, what is the momentum, initial momentum? Speak out.
1000
kg
kg.
meter per second.
1000 kg meter per second.
Second.
So now shall
Sir,
we
in
go?
this also average momentum will be there, sir.
You can at different intervals you can find out the momentum and take a average momentum. So how to find the average momentum? You have to find the average velocity. And then you will get a average momentum if we multiply by mass. Now we will find out the final momentum, and final momentum is m into v, not mu. So what is mv? V is 20 meter per second. Now tell me what is the answer?
20,000 kg.
20,000 meters.
20,000 kg meter per
Slight wrong
second.
here. This is
Kg.
20,000 kg meter per second. Okay.
Sir, it is vector quantity, na sir?
I'll come back to that. Okay, kg meter per second. And next, this is how we can find out initial momentum and final momentum. Let's say we have found out the initial momentum and final momentum, right? What is the change in momentum? What is the change in momentum? This is
The final
20,000
Versus initial momentum.
20,000 kg meter per second. Change in momentum is final momentum.
Sir, 90,000 kg meter per second.
Yes, sir.
Final momentum minus initial momentum. And final momentum we can write it as m into, tell me what, is it u or v?
M into V minus M into U, sir.
minus m into
m
v.
into u, correct? So that is change
Yes,
in
sir.
momentum, right? Now that will be equal to 20,000 minus 1,000, which is equal to how much? 19,000
19,000.
meter kg
Sir,
meter.
if they gave initial velocity, final velocity, and all, and thus they told to find momentum, means what we
exactly.
should
Yeah,
find,
yeah,
sir?
yeah. Correct, correct. That you can find out. Okay, but interesting thing is, interesting thing is, I'll just come back here and put a blank slide here, because I just want to go for a blank slide and then make it on. Okay. Okay. So what we have understood is change in momentum is equal to mv minus mu, right? And what is mv? Final momentum, and minus this one is initial momentum. Now suppose change in momentum per unit time. Listen to my sentence. Change in momentum per unit time means I have to divide by time. Right? When I divide this by time, I have to divide here also. Correct? Are you getting it?
Yes,
Hello?
sir.
Yeah. So what I do is change in momentum divided by time is equal to m in the bracket v minus u divided by t, which is equal to, so let me write change in momentum,
Acceleration.
change in momentum, very good, momentum per unit time.
Sir, mass into
Sir, change in momentum per unit time is force.
Mass
mass
into
into
what?
acceleration.
What should I write?
Acceleration.
Acceleration. Why acceleration?
Acceleration.
Acceleration is v
Because
minus u divided
V
by
minus U divided by
D.
T.
divided by
Yes, sir.
t.
Sir, this
That
is
means,
proportional to force.
Yes,
what is
sir.
this m into a?
Moment.
Nothing but force.
Yes, sir.
Now force can also be defined as,
Momentum.
no,
Change in momentum.
Change in
change
momentum.
in
Change in
momentum,
momentum.
not
Per
only
unit
change in
time.
momentum,
Per unit time, sir.
per unit
Time.
time.
Sir,
Now very interesting thing I'll tell you here. Okay, Chandru, you want to speak something?
sir, without finding acceleration, sir, we can find the force.
Yes, yes. Now you see F is equal to, let me say, m into v minus u by t. Now t is in the denominator. Okay? T is in the, please remember, t is down here, denominator. If this becomes very less, value of this becomes less, what will happen to force? Tell me, what will be the value of this force?
Sir, force will increase.
Very good.
Increase.
Yes, sir. Force will increase.
Force will increase. Let's say a Bruce Lee's hand is, this is a Bruce Lee's hand, okay? And he is punching, right? It has some mass, and he is punching on the wall here, right? And after some time, it hits on the wall, right? That means he is applying a force. And that force depends on the time. And time should be very less to have more force. Did you understand now?
Yes,
Yes,
sir.
sir.
Yes,
That
sir.
means he should be as quick as possible. Yeah, Bruce Lee is known for his very famous 1-inch punch. Okay, he was generating so much of force. And why he was generating so much of force? Because the time, when he starts from here to here, the time which he was taking was much less than anyone else.
Sir, time always matters in force, na sir? then?
Yes, as the time is less, the force generation is so much. Understood? So this is what about the strange thing about momentum. Okay, and now if you want to apply more force, you understood now. You have to minimize the time of two events.
Okay, sir. Now understood
Yeah,
everything.
minimize the time of initial momentum and the final momentum. Between that, you have to minimize the time, right? So what I'll do here is I'll just stop the video.